Okay, so now let's move on to the next one, that is question number 6. Now we'll see. We'll tackle the question number 6 now. So here we have x equals to log 1 plus t square, then y equals to t minus tan inverse t, and then you have to show that dy by dx equals to square root of e raised to x minus 1 upon 2. So as I told, whenever we are dealing the sums with respect to show that, just simply you have to focus on show that. From there you will get the idea what exactly we have to do. Okay, and we will come to know that which all terms are unknown things, unknown terms. Okay, so here we required e raised to x minus 1 and 2, and even square root also, but the given question, it is in the form of log and tan inverse and t. Okay, so here we have to eliminate log t and tan inverse. So for this sum, your log t tan inverse is unknown term. Okay, so let's see the presentation now. Okay, so here the first thing is what we know, the log formula for this sum. If you want to tackle this sum, so just before that we'll see a basic things. Okay, so here we know the formula, that is log b to the base a is equals to x. This is what logarithm form. So when you convert this log into exponential form, you will get a raised to x equals to b, and we know that wherever we see log e, and the value of log e is what, it is equals to 1. Okay, and even we know that log b equals to x. Suppose in the base if nothing is there, so basically we always take the base as common, we take the natural base as e. Okay, natural base as e. Okay, so here suppose in case in the base nothing is there, so straight away you take e as a base. Okay, it is a natural base. Okay, so when you will convert this logarithm form into exponential, so here you will get e raised to x equal to b. Okay, now let's begin with the sum now. So x equals to, here we have log 1 plus t square. Again, for this sum also there are 2-3 different methods. Okay, so out of that 3-4 methods, we're gonna select the simplest and the easiest method. So in that, so we'll choose the simplest and the easiest method. So I will try to explain the sum in the easiest way. Okay, so here x equals to log 1 plus t square. Okay, as if you want, if you feel that we can do some basic adjustment, you go ahead with that, or else you can start directly with a derivative with respect to x or any parameter which is there. As here, as I told, for each and every sum, the concept and the method, it is different. Okay, there is no, for each and every sum we don't have a common steps. Okay, common method. Okay, so for this sum, what I will do here, okay, I will use the concept of parametric form. Okay, so here directly I will start with derivative with respect to t. Okay, as here the parameter on the right hand side, here we have t. Okay, so here you will get what, dx upon dt equals to this look like what, this look like what, a log t, this look like log t. Okay, but t is replaced by some other term. As we are finding the derivative with respect to t, so your t will act as x. Remember this. Okay, so we know that derivative of log t, derivative of log t, derivative of log t with respect to t will be what, 1 upon t. Okay, so here you will get 1 upon 1 plus t square, because t is replaced by 1 plus t square. Okay, so we know that whenever t is replaced by some other term, so we have to use the chain rule. Okay, so t is replaced by what here, 1 plus t square, because as I told, here t will act as x. So whatever the formula it was there for x, okay, it will go for t also. So after this, 1 upon 1 plus t square into, now we have to find the derivative with respect to t. Check out how many terms are there. There are two terms. Derivative of one will be what? A 0, and derivative of t square using x raised to n, you will get 2t. Yes or no? So therefore, here in the next step, you will get dx upon dt equals to 0 plus 2t, you will get 2t upon 1 plus t square. So here we got dx upon dt. Okay, here we got dx upon dt. Okay, so now after this we'll find dy upon dt. As I told, for this sum I will be using the parametric concept. So first we'll find dx upon dt. On the other hand, on the second part here we'll find dy upon dt. So let's see what we will get. Okay, so y equals to t minus tan inverse of t. Again same, if you feel if you can do some basic adjustment, then go ahead. Otherwise, we can start directly with a derivative with respect to x. So here for this sum, you will get dy by dt equals to, here clearly we can see that there are two terms and the connection between them, it is plus and minus. Plus or minus means individual derivative. Yes or no? Okay. So derivative of t, as I told, t here it act as x. Okay. So derivative of t with respect to t will be what? 1, and derivative of tan inverse t. Okay, so your t act as x, whatever the formula it was there for x, it will go for t also. So here you will get 1 upon 1 plus t square. Okay, so derivative of t will be what? 1, and derivative of tan inverse, we know that it is 1 upon 1 plus t square. And clearly we can see that in place of t, t is there. Okay, so here t is not replaced by some other term. So here there is no need to use the chain rule concept. So as we know that chain rule is what? Whenever that section, that part, if it is replaced by some other term, we have to use the chain rule concept. Okay. Okay. So after this, what I will do? Here simply I will do the cross multiplication. So here you will get 1 plus t square minus 1 upon 1 plus t square. Here 1 will get cancelled. So you will be left with what? Dy upon dt is equals to t square upon 1 plus t square. Okay. Now, so here I will give this part as 1 and this as 2. So dividing 2 by 1 or from 1 and 2, here you will get dy upon dx. How you will get dy upon dx? When you will divide dy by dt upon dx upon dt. So dy upon dx is t square upon 1 plus t square. Okay. And here it is 2t upon 1 plus t square. Okay. So here t square upon 1 plus t square. So when you will multiply, okay, as it is in division. Okay. So when you will do multiplication here, so it will get reciprocal. So this will be 1 plus t square upon 2t. So as clearly we can see that 1 plus t square is common. Here we can cancel out 1t. So here we left with what? T by 2. So here we got the answer, that is dy by dx is equals to t upon 2. Here we got dy by dx. Yes or no? Clearly we can see that we got dy by dx. Yes, we got dy by dx. Yes or no? We got dy by dx. But on the right hand side, here we required square root of e raised to x minus 1 upon 2. Okay. So that is missing here. Okay. So now see the adjustment what I will do here. Okay, so here after this, just focus on this step. What I will do, We'll give this as equation number 3. You will come to know afterwards why